بسم الله الرحمن الرحيم.
Assalamualaikum. Hi guys, welcome to another part of 8810 ORP analyzer, which is related to plotting ORP graph to get correct endpoint to finish our titration process. As you know, in our last part we discussed about the measurement menu. In measurement menu we have three sub menu, which is number one is auto endpoint, number two deviation, and number three is endpoint. During titration, analyzer use the auto endpoint method to calculate concentration of calcium. In this method, analyzer continuously monitor the rate of change of millivolt reading. The point when the millivolt rate of change is highest, analyzer consider this point as the endpoint of titration for calcium concentration. The other endpoint only used to stop the titration process after getting auto endpoint. So I think you're confused. Don't worry, I will explain it through 2D graph. I will draw a graph between millivolt reading and titration time. On y-axis, I will keep millivolt, and on x-axis, I will keep titration time. Now, if you draw a graph between millivolt and titration time, you will get graph something like this. Usually, after dosing conditioner, titration will start in between plus 10 millivolts to plus 50 millivolts. And as you know that we configure our application menu as 1 point descending potential. If you don't know about this, I will recommend you to watch our second part of this analyzer where we did basic configuration of this analyzer. Okay, 1 point descending potential means when titration will start, the millivolt reading start to decrease. In this case, the millivolt reading start to move towards negative side. Now I will discuss this graph in detail. Usually after conditional dosing, titration will start most probably in between plus 10 millivolts to plus 50 millivolts. When titrant pump starts, for 2 to 4 minutes, millivolts reading start to decrease very slowly towards negative side. After continuous injection of titrant, this millivolt rate of change start to increase. And one point will come when this millivolt rate of change, the millivolt reading rate of change becomes so much high so you cannot count by your mouth. In fact, this is auto endpoint of titration to calculate calcium concentration. Then you will see the rate of change of millivolt reading start to slow down. And one point will come when this millivolt reading become constant. Now I will show this you in real time. For this purpose, need to switch your analyzer sequence mode to plot ORP. This we will do by using programming menu. If your analyzer is not stopped, first stop your analyzer and go to the programming menu.
When analyzer in service, it will display titration or fixed time. Usually it displays milligram per liter unit, not millivolt. You can select any of these units by pressing up or down keys. The display menu can be changed by pressing select key. Now if you scroll through all options of main menu, you cannot find programming menu because analyzer in service. To use programming menu, it is required to stop analyzer. After stopping analyzer, again press select key to come to the main menu. Then move to programming menu. Press and hold enter key until measurement display. Then scroll down to sequence menu and press enter. Then go to plot ORP option and press enter. It will ask you to enter your ORP plot range. Enter start I minus 500 millivolt and end I plus 500 millivolt. Then press select key to come out from programming menu. After this, start analyzer again. Now you will see analyzer operating in plotting ORP mode with millivolt unit. It will follow normal operation sequence. First, sprinkler will rinse electrodes 3 times. Then sample inlet valve will open and drain valve will drain some quantity of sample for short time and then close. After this, sample level rise up to overflow tube and flow through overflow tube for short time. Then sample inlet valve will close and siphon will activate to maintain accurate volume of sample. Then stirrer will come in action. After 8 to 10 seconds, conditioner pump will inject the conditioner for 20 to 40 seconds to raise pH of sample to 8.3. Plus minus 0.2 deviation is acceptable. Now look at the millivolt reading. It will stabilize in between plus 10 millivolt to plus 50 millivolt. You can see it is starting from 19 millivolt. After that, titration pump will start. Now keep attention on millivolt reading. In the beginning, from 2 to 4 minutes, millivolt rate of change will dead slow. You can see it. It is decreasing slowly. To observe this trend, need patience. So with patience, observe this trend because it is backbone of analyzer operation. I will give you surety. If you understand purpose of plot ORP sequence, you can handle 80% faults of this analyzers. You can see again, still millivolt decreasing slowly. Millivolt rate of change still slow. Another thing I want to tell you about this, that the trend which you are observing now, it belongs to healthy electrodes. The starting and end points of trends can be drift time to time, but shape of healthy trend should be like this. Start point can be more than plus 50 millivolts or less than plus 10 millivolt, and end point can be more than minus 35 millivolt or less than minus 90 millivolt respectively. But orbit trend should trace same path as we are observing now. Keep in mind that titration should not start from too high value, for example plus 200 millivolt, or from too low value, for example minus 200 millivolt. If it is like this, it means any of one or both electrodes need replacement. Sometimes this millivolt reading is erratic. It may happen due to following problem. Number 1, may your conditioner reagent is not correctly prepared, which you can verify by pH value of sample after injection of conditioner. It should be 8.3 plus minus 0.2 pH. Number 2, may your conditioner pump unable to inject sufficient conditioner due to aging of pump's tube. Number 3, may electrolyte of ion selective electrode need to refill. Number 4, may any one or both electrodes need replacement. As I told you, it is too slow and boring process. In real time, it is slower than what you are watching now. I have already increased speed of video to 170% to keep your interest in this process. Now you can see after 0 millivolt, the rate of change of millivolt start to increase, but still you can count it easily. Usually after this, I start to count millivolt value silently to catch that point of millivolt value, after which rate of change of millivolt becomes so high which I cannot count. Keep observing millivolt rate of change. It is increasing. You can see millivolt reading decreasing, which represents correct titration process. After minus 20 millivolt rate of change speed up, which means it is near to auto endpoint. May you observed that after minus 35 or minus 40 millivolt rate of change is highest and remain high till minus 95 or minus 100 millivolt. After minus 100 millivolt, this rate of change start to decrease. And at last, after minus 126 millivolt, it become constant. Then stop analyzer, otherwise titration pump will remain in running condition. Now we will see which value is auto endpoint and which value we have to enter as endpoint. In this trend, you can see millivolt rate of change is highest at minus 35 millivolt or minus 40 millivolt. So these points analyzer consider as auto endpoint. Don't worry about it. This is responsibility of analyzer to get auto endpoint. But we have to give endpoint value to stop titration process. You can see a red line where slope is steep. Any point on this red straight line you can give endpoint. The middle of this line is recommended as endpoint. In this case, minus 70 millivolt is middle value of straight line. So we enter this value as endpoint. Now question is, why endpoint recommended in center of straight line? As I told you, time to time auto endpoint value can drift towards negative side or towards positive side. If you choose your endpoint at the beginning near to endpoint, say minus 42 millivolt, and after some time if auto endpoint start to drift negative side, then you will get low reading of calcium or may zero reading of calcium concentration. In other case, if you choose endpoint at the end of straight line, say minus 100 millivolt, and auto endpoint start to drift positive side, and it is possible and came to that region where millivolt reading remain constant, which will not stop the titration process. When this titration time increase more than titration time limit, say 15 minutes, then analyzer will display over titration alarm and last reading remain on hold. Then you have to acknowledge the alarm and have to start analyzer again. So better to keep endpoint in the middle or lower than middle. Okay guys, in this part we discussed purpose of plot ORP sequence, basic operation of analyzer, plotting ORP graph, auto endpoint, and two types of issues, low or zero reading issue, over titration alarm, purpose of over titration time limit parameter. We have discussed about the behavior of healthy electrodes and also observed the trend of healthy electrodes.
Okay guys, hope you understand the purpose of plot ORP sequence and how we can use it to get our auto endpoint as well as health verification of both electrodes. This is very easy job, only it is time taking job. You need patience, same like as your parking car in Paris. After this, now we are ready to perform calibration, which we'll perform in next part of this analyzer where I will show you the different types of calibration. Till then, ma'as salam, Allah Hafiz, see you.